Hello everyone, welcome back. In this video we're going to take a look how to insert elements in sorted order in a singly linked list data structure. Say the user want to insert number 3, number 2, say number 5, number 8, and number 6. If we use the insert at n function, so our linked list is going to store this element as they are inserted, but we don't want that. We always want to maintain a sorted order in our linked list, either ascending order or descending order. So we want to have our linked list store the elements as sorted, say 2, 3, 5, 6, 8. No matter in what order the user insert the elements, we always store them in a sorted order in our linked list. So to do that, what I'm going to do is I will go to my linked list class. I will define another function here. Let's call it public void insert in sorted order. This function is going to take data. Then the first thing we will do using this data, we will create a new node. Let's create a new node, a new node equal to new node of data. So say the user want to insert number 3. The first thing we will do, we will insert create a new node having the data. The user inserts number 3. The next pointer of this new node will point to null, and we have a reference variable called new node points to this node. Definitely the memory manager will assign a memory address to this new node. Say the memory manager assign number 100 or memory address 100 to this new node. We will also have a head pointer and a tail pointer in our linked list, initially pointing to null. We have a tail pointer also equal to null. So we will check if the list is empty, this new node will become our head pointer and tail pointer. So let's check for that. If this dot head equal to null, so this new node is going to be the first node in our linked list. We will set this dot head equal to a new node, also this dot tail equal to new node. So let's do that. I'm gonna copy this newly created node and paste it over here. So we will have our head pointer point to this node, also the tail pointer, since we have only one node in our linked list. Then there are 3 situations after we insert the elements. The elements to be inserted will be either inserted before the head node, or after the tail node, or at end of the linked list, or in the middle of the linked list. So we are going to take care of all these 3 corner cases. First, we will check if the new data to be inserted is less than or equal to the head's data, which is number 3. If that is the case, we are going to insert the new node or the new data at the beginning of the linked list. So say the user want to insert number 2, we will call again the function insert in order. The first thing is function will do, we will create a new node using the data. So this time, say this new node is created having number 2 with memory address 200. So we will check if new nodes.data or the data is less than heads.data. Yes, number 2 is less than number 3. So we are going to insert this new node at the beginning of the linked list. We also know how to insert a node at the beginning of the linked list. It is very simple. So we are going to create a link between these 2 nodes like this, having new node.next, which is this pointer, point to this memory address. So we can say if the condition is true, we will say new node dot next pointer equal to head. Since head stores memory address 100, so instead of null we will have 100 here. Right now this newly inserted node is the first element in our linked list, so we are going to update our head pointer and bring our head pointer to this node. We will say head equal to new node head comes here. We successfully inserted 2 elements in sorted order in our linked list. So let us in the else if block, I'm gonna check if else if data is less than or equal to this dot head dot data. We are going to insert it at the beginning of the linked list by saying a new node dot next equal to this dot head, and we update our head pointer this dot head equal to new node. Else we are going to check if the data to be inserted is greater or equal to the tails data or the data at the end of the linked list. Right now end of the linked list is this node, so we'll check that if the data is greater or equal to this node's data, we will insert it at the end of the linked list. So say the user want to insert number 5, we will call our function. The function is going to create a new node having number 5. Say the memory manager assigned a memory address 600 to this new node. So we don't have new node pointers anymore to these nodes. So new node is going to point to this newly created node. We will check if the list is empty. No, the list is not empty. Again, we will check if the new node dot data or the data is less than heads dot data. No, 5 is not less than 2. We will again check if this new data is less than is greater or equal to tails dot data. Yes, number 5 is greater or equal to the tails dot data. We are going to insert this newly created node at the end of the linked list. So what I'm gonna do is I will copy this and paste it here. We also know how to insert at the end of a single linked list using the till pointer. We will say till.next, which is this pointer, point to memory address 600 or the new node. We will have it like this. We will say till.next equal to new node. Once we set that, so instead of null, we are going to have memory address 600 here. Then since this newly inserted node is the last node in our linked list, we are going to update our till pointer. We will bring the till pointer here, have it point to new node. Till comes here. We'll say till equal to new node. So let's write code for this one also. Else if data is greater or equal to this dot till dot data, we are going to insert it at the end of the linked list using the till pointer. This dot till dot next equal to new node, and we update our till pointer this dot till equal to new node. If none of these conditions are true, then definitely the newly inserted item will be inserted at the middle of the linked list somewhere. Say the user want to insert number 8 this time, so we create a new node having number 8 with a new memory address, say 900, and the new node is going to point to this newly created node now. So we will check if the data or the new nodes dot data is less than heads dot data. No, it is not less than 2. We will again check if new node dot data or the data is greater or equal to the tail dot data, which is number 5. Yes, condition is true. We are going to insert it at the end of the linked list. Same we did with number 5. So I'm gonna paste it here. So we will say till.next equal to new node, till.next, which is this pointer, equal to new node. New node stores memory address 900, so instead of null we are going to have 900 here. Then we will update our till pointer, till equal to new node. So till pointers comes here, since this newly inserted node is our last node in the linked list, so till points here. Then we are going to insert number 6. Again, we're going to call the function. The function creates a new node having number 6 with a new memory address, say 150. So new node points to this newly created node. We will again check if data is less than head.data. No, 6 is not less than or equal to head.data. We will again check if data is greater or equal to tail.data. No, 6 is not greater or equal to 8. So definitely this node is going to be inserted somewhere in the middle of the linked list here, excluding the tail node and the head node, or excluding beginning of the linked list or end of the linked list, somewhere in this area. So what we are going to do, we will start traversing over the linked list until we find an appropriate position to insert the new node, in this case 6. So what I'm going to do, I will set a pointer to a head node, let's call it temp pointer, to traverse over the linked list. So I'm going to define node temp equal to head. We will check until the temp.next or the next node of the temp node is not null. We keep looping, and also we check until the data is greater than temp.next.data, which is this node's data. We keep looping and we update our temp pointer. We check while temp.next, which is this pointer or the next node of the temp pointer, is not null. Also we check and using an AND operator, and until data is greater than temp.next.data. We check the temp's next node data, which is this node, temp.next, which is this node, .data, which is this data. So let's do that. While temp is not equal to null, no, temp.next is not equal to null, temp.next is memory address 100, condition is true, and data is greater than temp.next.data, data which is number 6 is greater than temp.next.data, which is number 3, yes, condition is true. We go inside the while loop and we increment our temp pointer. So let's do that. We say temp equal to temp.next. So temps come here. We will again check if while temp.next is not equal to null, no, temp.next is memory address 600, it is not null. We again check if temp.next.data, temp.next, which is this node, .data, which is this data, less than, when data is greater than this data, yes, it is, 6 is greater than number 5, the condition is true. We again go inside the while loop and increment our temp pointer, temp comes here. Again we'll check temp.next is not equal to null, no, temp.next is not equal to null. Data is greater than temp.next.data, data which is number 6 is greater than temp.next, which is this node, .data, which is this data, no, condition is false. We exit out of the loop and we found a position in which we want to insert this newly created node having number 6. So once we got a temp pointer here, in the previous videos we saw using this temp pointer we can easily insert a new node at this position. Say I have my new node here and I want to insert it in this location. What I can do is I will first say new node.next, which is this pointer, equal to temp.next, which is this node or this memory address 900. So I'm gonna establish a pointer here like this. After the while loop I will say new node.next equal to temp.next, which is the next node of the temp pointer. Temp.next stores memory address 900. So instead of null we are going to have 900 here. Then we are going to say temp.next equal to new node. We are going to break this connection and we will make another link between the new node and the temp pointer, saying temp.next equal to new node. So here we'll say temp.next equal to new node. So temp.next instead of pointing to memory address 900, this time it's going to point to memory address 150. So this way we can insert items in sorted order in a singly linked list data structure. So let's write code for this last condition, else. We definitely know we will insert at the middle of the linked list. So I'm going to do, what I'm gonna do is I will create a temp pointer node temp equal to this dot head, while the next node of the temp node is not equal to null, while temp, let's give it a p also, temp dot next is not null. Also while data is greater than temp.next.data, we update our temp pointer saying temp equal to temp.next. Once we exit out of the loop, we found an appropriate position to insert the new data at the middle of the linked list, so we can insert it using the new node dot next pointer equal to temp dot next. Then we will set temp dot next temp.next equal to new node. Once we insert it, at the end we are going to increment the size of the linked list, this dot size plus plus. So let's check this. Sorry, it's len, I think, this dot len plus plus. Let's check the code. I'm gonna comment out these lines of code. I'll say list dot insert in sorted order. Say I want to insert number 3, and then if I insert number 2, Control D, and then we inserted number 5, number 8, and 6. So we should have a sorted linked list no matter in what order we insert the items. Yeah, we have 2, 3, 5, 6, 8. Say at the last I want to insert -1, so -1 should be the head node. Yes, -1 is the head node. Say at the beginning I want to insert number 300, so 300 is inserted initially at the beginning. It should be the tail node. Yes, 300 is the tail node. So this way we can insert elements in a singly linked list in sorted order. Thank you guys for watching. Please don't forget to subscribe to Code with Cougar, and see you in the next video. Bye bye.